In this video, we are going to learn how to identify igneous rock. As a warning, this video may be more educational than it is entertaining. Now, before we begin working through an actual specimen, I want to take a couple moments to talk about the various charts you can use to help identify your igneous rock specimens. All of these charts will be available online through our learning management system. So let's take a look at our first chart here. Deals with our felsic and our mafic minerals. So our light colored minerals and our dark colored minerals. Again, these minerals here should seem familiar in that these are many of the common minerals you identified in your mineral specimens lab. If we look on this side over here, this again will help you figure out texture. So dealing with phaneritic, porphyritic, aphanitic, glassy, and vesicular. And for a review of those terms, you can review our igneous rocks properties video. And then last but not least, the actual chart where we can learn our rock names. Here we have an image where we can see the top. Mafic color index ranges from 0 to 100%. So from no mafic minerals to completely mafic minerals. Okay. If we come up a little bit, we can see here our felsic rocks, so things with a low mafic color index. These will be the minerals that could possibly be in that rock. An intermediate one, again, these are the minerals in here that could be within that rock. And then of course our mafic ones here and the possible minerals that can be in it. Okay. To give you guys some help, none of your specimens will qualify as ultramafic. Now if we come up to the last part of our chart here, we can see that again it's broken apart by our texture. So our slow cooling rocks from intrusive origins, so within Earth, and our faster cooling rocks, so extrusive origins, so near or at Earth's surface. And we can see granites, diorites, gabbros, rhyolites, andesites, and basalts, and of course obsidian, pumice, some of our more common igneous rocks. So the way to read this is that if you had something similar to very little on the mafic color index, these would be the possible minerals that they could be. Depending on their texture, this would be the possible rock names that they would be. That's how you read these charts. So hopefully you are now ready to work through an actual specimen. Okay. We're going to be working through this one here, number 17, from our igneous rock specimen. Now, to make this easier, what we've done, and I'm going to be having the help of my assistant again, this should be your whole chart to give you an idea of our various categories. Okay. Now, because there are numerous specimens, what we simply did is fold it over a specimen so that way we can actually see what we're working with. So let's start. So in this specimen here, okay, that I'm holding on, we can see that we have various crystals that we can see, and no matter what size or what side we look at, no matter what size we're viewing, the important part is that they're all visible. So an igneous rock with all visible crystals should be what kind of texture? Hopefully you said phaneritic. Good. So in our chart, we will write phaneritic for our textures. Now, for minerals present and their percent abundance, I like to do that one after I've determined my mafic color index because it helps eliminate some of the possibilities. So now, when looking at this specimen, you might look at it and you might think that the darkness is your ally. But remember, the dark or the shadows can betray you. So what I always encourage my students to do is focus on the light. Now, if we look at it, we get our chart up here, we take our specimen, we can see that if we start all the way over on the light, we can see that there's too much dark in this specimen here to be considered 0 to 15. If we come over here to our 15 to 45, again, this specimen is too dark for that aspect. We come all the way over, we can see that now we have a mafic color index that is similar to my specimen. Now in this specimen here, I would probably consider this to have a score of, say, a 70% on my mafic color index. So we would write 70% in our mafic color index. Now, with that being said, I'm going to move our chart off to the side here real quickly. If we can come down, we can see that I only have a certain number of minerals that could be in this rock. Now, I'm going to look at it and say that again, most of my blacks and my darker minerals fall under that pyroxene category. Some of them might fall under the amphibole. And then my lighter ones, my grayish ones that are in here, even my grayish blue ones that might be in here, fall under the plagioclase feldspar percentage. So for my categories, what I'm estimating, I would say, for my plagioclase, and you can abbreviate that PLAG or any abbreviation of plagioclase is fine. Okay, and then I would say I have approximately 30%. And I determine that by simply looking at the surface. For my pyroxenes, okay, and I often abbreviate that PYX, I say I have approximately 60%. Again, a rough estimation by looking at the surface. And again, I think I have some blacks in there that have that nice pattern that we saw from our amphiboles last week. So I'm going to say amphibole. AMP is how we abbreviate it. And I'm going to estimate approximately 10%. Now, with that being said, we should have enough to have an idea of how to identify our rock name. So if we remove our chart one more time, we come down into the mafic category. So I'm going to block off the mafic category here. I'll block off the mafic category there. We can see these dashed lines continue straight down. So let's come up. If I continue my boundary lines down, okay, we can see that that boundary line puts me into these possible rock names. Now, in order to automatically start getting rid of some of the categories, we agreed that this specimen was a phaneritic specimen. Okay. So, come over, drawing through my phaneritic category, and I realize that the only category that they overlap in is what we call a gabbro. This specimen, number 17 that we are identifying, is considered a gabbro. So we would simply fill in gabbro into our areas there. And now, for the last category, what geologic setting or environment might you find this rock in? There's a number of things within your lab books, lecture books, or online that you can use to help identify where this possibly came from. And that is how you identify an igneous rock.